I want to quickly derive a useful identity for dealing with expressions like this. So I have a cosine of one argument multiplied by a cosine of a different argument. So in calculus, for example, if this appears inside of an integral, you're stuck and you need a trig identity to get unstuck. These expressions also pop up occasionally in physics, and you might want to rework them into a new form to get a better physical intuition for a problem. So the derivation all starts from remembering what the cosine of a sum of two angles is. You get cosine of the first, cosine of the second, minus sine of the first, sine of the second. If I then look at a cosine of a difference of two angles, you get cosine of the first, cosine of the second, plus sine of the first, sine of the second. And now we're going to exploit the symmetry of these formulas and just add them together. And when I do that, the sine containing terms die, and I end up with cosine theta plus phi plus cosine theta minus phi is equal to twice cosine of the first angle, cosine of the second angle, which is exactly the kind of expression that we're trying to get an identity for. Solve for it real quick. And I have cosine theta cosine phi is 1/2 cosine of the sum of the two angles plus cosine of the difference of the two angles. So let's apply this thing. I'm going to let theta be 2x and phi be 3x. So I get the cosine of 2x plus 3x, that's 5x. And then the cosine of 2x minus 3x, that's negative x. And just to make it a little cleaner, I use the fact that cosine is an even function. So the cosine of negative x is equal to the cosine of positive x. So in the context of calculus, if you're stuck with this thing in the integrand, you're in trouble. But if you see this in the integrand, those are both easily guessable integrals. So the one impossible integral turns into two easy ones, which is a fair trade.